Welcome back, everybody. We've got one last in Chapter 2, our Logic and Reasoning chapter. And in Section 2.6, we're going to prove angles congruent. What we're going to do is we're going to take all this logic and reasoning stuff we've been doing and really show you how it helps us kind of figure more stuff out in geometry. Okay, come up with more formulas, come up with more properties. Okay, so proving angles congruent, that's kind of a general thing. We're going to look at really one theorem, one kind of property. That's going to be the vertical angle theorem. We'll prove why that's true and then show you how to use it. All right, so before we get into the vertical angle theorem, let's take a look at something we know how to do already from Chapter 1. Let's say I have a geometric figure here, and we want to find the measure of each numbered angle. Okay, well, again, this is something we could have done in Chapter 1. Since I'm given this 43 here right off the bat, I can figure out what angle 2 is because I have a linear pair. Okay, so I know that angle 2 is just going to be equal to 180 minus the 43. So in other words, 137 degrees. Okay, and then from there I can do the same thing. I've got another linear pair between angles 2 and 3. So we can say angle 3 is equal to 180 minus angle 2, which is the 137, which would be a 43 degrees then. And we can do that one more time with angles 3 and 4. Again, linear pair, so we can say angle 4 is just equal to 180 minus angle 3, which is 43 again. Or we could think about this 43 we started with, and we get the 137 once again. Okay, so again, something we could have done in Chapter 1. Now, let's use some of our logic and some of our reasoning here. Let's take a look at what happened with this example. Okay, notice that 43 and angle 3, which are vertical angles, ended up congruent to each other. Okay, they have the same measure, they're both 43 degrees. Same thing with angles 2 and 4, they're both 137 degrees, so they're congruent as well, and they're vertical angles as well. Okay, so using inductive reasoning, the pattern I'm noticing here is that it looks like vertical angles are congruent. And kind of based on this math we did, it kind of looks like that's always going to be the case. Because all I'm going to have are linear pairs, and if I subtract the same thing from 180, I'll get the same answer. So we just made a conjecture about vertical angles. Now I'm going to say that a theorem is a conjecture or a statement that you can prove is true. Okay, so conjecture, we make a guess based on a pattern. We're going to say a theorem is something that we're not just looking at the pattern, we're going to prove that it's true using deductive reasoning instead of inductive reasoning. So what we have then is our first theorem of the course. I'm going to say the vertical angle theorem. I'm going to say that it is that vertical angles are congruent. So in the case of this figure, we'd say that angles 1 and 3, which are vertical, are congruent to each other. Same thing with 2 and 4, they're vertical, so they're congruent. Okay, we notice a pattern. Now let's show you quick what a proof would look like. Again, this uses our deductive reasoning, our chaining conditional statements together. You don't need to copy this down, but we'll show you how this works just so you kind of believe that vertical angles will always be true. Okay, we'll start off with an if. We'll say if angles 1 and angle 3 are vertical, I suppose you'll say angles. All right, and we also need to talk about angle 2. Angle 2 is adjacent, so in other words, between angles 1 and 3. So adjacent to angles 1 and angle 3. So if we have vertical angles, in other words, then what's going to happen, then I know that if I add angles 1 and 2 together, I get 180. And I can do the same thing with angles 2 and 3. We could say angle 2 plus angle 3 equals 180. Okay, then what I can do is some equation trickery here. Since I have two equations that are both equal to 180, what I can do is I can set those equations equal to each other. I can say that angle 1 plus angle 2 is equal to angle 2 plus angle 3. Oops, pen just went crazy there. Ah, go back, go back. There we go. Comma, there we go. All right, again, since both those equations were equal to 180, I know that the parts on the left side have to be equal to each other as well. And then what I can do is essentially have an equation with an angle 2 on both sides. If I subtract that angle 2 from both sides, what I end up with are then we can say that angle 1 and angle 3 are congruent. Whoops, we'll just make a equal sign here. It's turned into a mess, but I don't feel like starting over. Angle 1 is equal to angle 3. Okay, therefore, angle 1 and 3 are vertical angles. I can say therefore instead of a final then. Therefore sounds fancier. We can say vertical angles are congruent. Period. Pen doesn't like me again. Okay, so that's an example of a proof. Just like we've chained if then statements together continually to come up with new conclusions. Same thing here. If we have vertical angles, then we know we have some linear pairs. Then we have some angles that are equal. Then the vertical angles are equal. Therefore, vertical angles are congruent. Okay, and in that proof, I didn't use any specific values for my two angles. I just used general values, angle 1 and 2. So what we showed here is that no matter what angles we have, vertical angles will always be congruent to each other. So let's show you how to use the vertical angle theorem now. Problem 1, part A says, what is the value of x? And it looks like I have two expressions that are on vertical angles. We just proved that vertical angles are always congruent. So now anytime we see vertical angles, mark them as congruent. And the equation to set up then is pretty simple. We'll just say 2x plus 21 is equal to 4x. And then I can solve it, subtract 2x from both sides. I get 21 equals 2x. Divide both sides by 2. We end up with x is equal to 10.5. Make my 5 look a little nicer there. There we go. Okay, so pretty simple. A lot of different ways we can use vertical angles, whether it's setting up equations or just solving for angles. The homework will show you some good variations on that. For now, part B is the same idea. I want you to pause the video, work through part B, and then click play to check your answer out. All right, part B, what is the value of x? Again, we have vertical angles. We know vertical angles are always congruent. We'll prove that for you. So we can say that 3x is equal to 2x plus 40. Okay, so real simple. Subtract 2x from both sides. And we end up with x equals 40. All right, so there you go. That's the vertical angle theorem in action. You don't have to be able to prove it. You just have to be able to use it. We'll prove results as a class using all the logic and reasoning we've done all chapter long, and then use that to make life easier to answer more math questions. Okay, so have at the homework. Give it a shot. If you get stuck somewhere, let us know. We're here to help you out.